Math 8, Unit 2, Transformations, Lesson 3, Part 3. Extending Learning, Reflections. You'll also get the assignment preview in this video. The vertices of rectangle A are A, B, C, and D. Draw the figure and its reflection in the x-axis and in the y-axis. Are the images congruent? Now actually, rather than, let's just go ahead and draw it real quick. A is at -4, -3. B is at -4, -1. C is at -1, -1. And D is at -1, -3. So here in red is the original rectangle. Okay, let's reflect it in the x-axis. Okay, reflecting it, B is 1 below. It looks like B prime is going to be 1 above. A prime is going to be 3 up. Whoops, not double prime, it's just A prime. C is 1 below, so C prime is 1 above. D is 3 below, so D prime is 3 above. And we get our reflection in the x-axis. Let's do our reflection in the y-axis. We'll do it in blue. So C is 1 away, C double prime is 2 away. D double prime, not 2 away, it's 1 away. D prime is 1 away because D was just 1 on the other side. B is 4 away, so B double prime is going to be 4 away. And same with A double prime. Okay, so there they are drawn. Are the images in part A and B congruent? Explain. So, are the images, the blue rectangle, congruent to the purple rectangle? Actually, I guess the question mark technically goes over the congruent symbol. Is it true that the blue rectangle is congruent to the purple rectangle, or the rectangle A prime, B prime, B double prime, C double prime, D double prime, congruent to the triangle, or the quadrilateral A prime, B prime, C prime, D prime? Okay, this actually kind of is the transitive property of congruence. If you have two figures that are both congruent to another figure, then they're congruent to each other. Both of these are congruent to the red rectangle, so they are congruent to each other. Yes. Okay. Consider this situation. You can actually reflect across any line whatsoever. For 8th grade, we're only focused on reflecting across the x-axis and y-axis. But what about across the line y equals x? By the way, first let me tell you why that's what it's called. Every point on this line, doesn't matter where you go, x and y are the same value. That's why it's called y equals x. Everywhere on that line, y and x are equal, so y does equal x. Okay, if I reflect this, let's see, didn't I draw the picture? Yeah, there it is. So this is kind of an interesting thing to reflect. Let me actually have that disappear again. I need to go the same distance from the line. So B is 1 diagonal away. B prime needs to be a diagonal away on the other side. And A is 3.5 diagonals. So I need to go 3.5 diagonals away. C is a diagonal and a half away. So C prime is a diagonal and a half away. And I do get that making the shape. So let's take a look at what happens with the coordinates. So A was at -3, 4, and A prime is at 4, -3. B is at 1, 3, and B prime is at 3, 1. C is at -4, -1. C prime is at -1, -4. Okay, looking at these for a pattern. Now, getting a 3, 1, and 4, -4, to become a 4, 3, and a 1, that's kind of messy. The first one you subtract 7, and you add 7, then you add 2, then you add 3. That's not consistent. In fact, this doesn't have anything to do with adding. Like the other reflecting, maybe it's a sign change. I don't see sign changes, but I do see that these switch places. So -3, 4 becomes 4, -3. 1, 3 becomes 3, 1, and 4, negative 1 becomes 1, negative 4. They do just switch places. That actually gives us an interesting coordinate rule. XY becomes YX. They just switch places. So no matter what my point was, if I was going to reflect it across the line y equals x, I would just take the 2 points and switch, or the 2 coordinates, and switch them. Now this is not one that you will be tested on. I just wanted you to see that the patterns, there's a lot of interesting patterns out there. Okay, for the assignment, number 1, determine whether the set of figures is a reflection. The figure with the star, the asterisk next to it, is the preimage. So these are yes or no. So 1A, look at those. No, it's a translation, so I would say no. Number 2, perform each transformation and identify the coordinates of the image. Reflect triangle ABC in the x-axis. So first I need to draw a triangle ABC. A is at 3, 2. B is at 4, 4. And C, that's a funny looking B. Let me try that again. B is at 4, 4, and C is at 1, 3. So here's the original triangle. Okay, it does say we need to reflect it in the x-axis. So we're going to go across the x-axis. A goes from being 2 above to A prime being 2 below. B is from 4 above to 4 below B prime. And C goes from being 3 above to being 3 below C prime. Okay, that's part of the problem, but it also says to identify the coordinates of the image. So I need to identify A prime, B prime, and C prime. Now you could pull these right off of the graph, or we know that when you do a reflection in the x-axis, x stays the same. So I pulled those from right there. That was a 3, not a 2. And the y switches signs. So 2 becomes negative 2, 4 becomes negative 4, and 3 becomes negative 3. And if you compare these coordinates with the points on the triangle that was drawn in purple, then they do match up. Okay, you'll want to do the other 3 of those kind of the same way. Number 3, you're going to solve an equation. Number 4, the 2 triangles are congruent. You're going to write an equation and solve for x. Number 5 is a scale factor problem. That's a review from 7th grade. Number 6, find the perimeter of a composite figure. That's a review from 7th grade. Number 7, which letters look the same when reflected? Now you're going to have to reflect these upside down. Now when you reflect A upside down, does it look the same? No, it doesn't. So A won't count. What about B? When you reflect B, does it look the same? It does. So B is one of the answers. And you just go through and figure out all of them that look the same if they're reflected up and down. Okay, number 8. Find the coordinates of each figure after the transformations. So you have to do multiple transformations here. Translate the triangle 1 unit right and 5 units down. Then reflect across the y-axis. So you're going to do the translate 1 right and 5 down, and then go across the y-axis. So if I go 1 right and 5 down, T goes 1 right and 1, 2, 3, 4, 5 down. That's T prime. R goes 1 right and 5 down. There's R prime. S goes 1 right and 5 down. There's S prime. Okay, we need to do one more thing with it. We need to go across the y-axis. So T prime goes from 1 away to T double prime, 1 away on the other side. R prime is 3 away. R double prime is going to be 3 away. And S prime is 3 away. So S double prime is also 3 away. And then it does say to identify the coordinates. So the coordinates are S double prime is located at 3, negative 1. R double prime is at 3, negative 4. And T double prime is at 1, negative 4. And then you'll do the same type of thing there on part B.